The discriminant. Determine if the equation has two real solutions, one real solution, or no real solutions. Now, before we determine how many solutions each of these equations has, let's just take a moment and recall the quadratic formula. The quadratic formula says that if you have an equation in the form ax squared plus bx plus c equals 0, and the coefficient of x squared, which we call a, is not 0, then we can find the solutions to this equation using the formula x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, the part of the quadratic formula, which is under the square root, the b squared minus 4ac, is called the discriminant. We call it the discriminant because it allows us to determine how many solutions this equation has. We know that if we have a positive number inside of the square root, then when we take the square root, we'll get another positive number, and x will be two different things. One when we add the square root of that number, and one when we subtract the square root of that number. So if the discriminant is positive, then the equation ax squared plus bx plus c equals 0 has two real solutions. If the discriminant were equal to 0, then in the quadratic formula we would take the square root of 0, which is 0, and when you add 0 and subtract 0, you would get the same thing, which means there would be only one value for x. So that means that this equation has one real solution. And the third possibility is if the discriminant is if the discriminant is negative. If the discriminant is negative, then the equation has no real solutions, because the square root of a negative number isn't a real number. Now, let's return to the three equations we were given, starting with the first. In order to apply the quadratic formula, the equation needs to be in the form ax squared plus bx plus c equals 0. The equation that we have in 1a is not in that form, so we have to add 4 to both sides of the equation in order to get this equation in this standard form. Now, since we don't need to actually solve the equation, and we just want to determine the number of real solutions, we can simply consider the discriminant, b squared minus 4ac. So, in this case, the b is negative 4. The a is the coefficient of the x squared, which is 1, and c is 4. Negative 4 squared is 16, minus 4 times 1 times 4 is also 16, and 16 minus 16 is 0. So, since the discriminant is equal to 0, then there is exactly one real solution to this equation. Let's look at part B. Again, I'm going to rearrange the equation so that's in standard form. Now, the discriminant would be negative 4 squared minus 4 times 1 times 8. So we have 16 minus 32, which is negative 16. Since the discriminant is negative, then there are no real solutions. Last but not least, part C. Arranging so we have the equation in standard form, we get x squared minus 4x minus 2 equals 0. So the discriminant is negative 4 squared minus 4 times 1 times negative 2. So negative 4 squared is 16, minus 4 times 1 times minus 2 is plus 8, and the discriminant is 24, which is positive. Therefore, there are two real solutions to this equation. Again, just to recap, if the discriminant is positive, the equation ax squared plus bx plus c equals 0 has two real solutions. If the discriminant equals 0, there's one real solution. And if the discriminant is negative, the equation has no real solutions.